Hello, everyone, and welcome. This afternoon's program will be really interesting. We have a presenter who is passionate about safety. Whenever we get in an airplane, we're going to take a risk. And risk management is how we get the joy out of the airplane, we get the joy out of the activity. And the technology that's coming our way is also capable of giving us great pleasure and great joy. But without risk management and without care, it can also be a killer. Buzz Massengill is an FAA safety inspector, and he is a FAST team program manager here in the southern region. Welcome, Mr. Buzz Massengill. Buzzing out there.
Thank you very much, Kathleen. I appreciate it. All right, well, thank you very much, and welcome to Sun and Fun. I hope you're having a safe time here at Sun and Fun and enjoying yourself. An awful lot's going on out here, and I know that many of you who fly, and just a quick set of hands, how many of you all are actually flying these days? Several of you. How many of you are flying what amounts to a glass cockpit now? Okay, a few of you. How many of you are planning on flying a glass cockpit in the future? Taking lessons, or you're looking at it? Great. How many of you plan never to get into a glass cockpit if you can help it? Okay. You know, a friend of mine in the FAA years ago said that the day he would learn how to use a computer would be the day that they figured out somehow jack it up and make it leak oil. Well, I'm afraid that those days have already come and left them behind. Now, I can fly like a lot of people, and I'm used to the old steam gauges or the round gauges, and I actually call them that, even though that's what's in use in an awful lot of the aircraft we're flying these days. But I've also had the benefit of going out and getting some experience with the new glass cockpit technology. I've ridden in several aircraft, and I know that in the air carrier business, if you fly on any of these airliners, all the Airbuses are flying with this stuff, and the new versions of some of the Boeing aircraft, they're also using this new technology as well. So you're going to see it just about everywhere. Now, I can remember, we've already come a long way. How many of you all remember things like the old radio range approaches? Some of you all actually probably flew some of that stuff. So as time has gone on, and now you keep flying, you've had to adopt to new technology. You've had to make that part of your life. So going on to technically advanced aircraft, technologically advanced aircraft, is not going to be as big a transition as you might think. Ask any 13-year-old, they'll tell you. You remember when 40 hours of flight training used to be the big deal to get you to the point to where you were stick and rudder qualified? It was mainly a mastery of flight technique. That's really what it was all about. That was what the good old days of flying were all about. Now, it's still the same 40 hours to become a private pilot, but look at how much more you've actually got to spend time working with in order to become fully aware of what's going on in the world. Now a lot of your time is being spent in doing the mastery of the technique as well as mastering technology. So you've got that added onto your plate. Now, I don't want to hear any complaints about it, because I know that a few of you all probably sat down and remembered the days when you turned on the television, you waited for it to warm up, and then you went over to the television and you twisted the knob to see the maybe 2 or 3 channels that were available. And then when something went wrong with the TV, you had a technician come in, pull, and change tubes. And you felt great when this thing gave you a 6-inch picture. Some of us actually remember that stuff. So now we've got down to the big audio-visual systems with large screen TVs, plasma, and all this other sort of thing. And this is part of our lives now. So even though the new technology could be a challenge to us, it's not going to be a biggie to the folks who are coming along. Ask any of the 13-year-old kids who've been brought up in the video game generation, and they'll tell you what it's all about. It's an awful lot of fun. So these folks are the future of aviation, and they're the ones that are going to kind of lead the way, and these are the ones that the technology is built for. But I'll tell you what, the new aircraft coming along today are also being built to replace the older aircraft, so more and more you're going to find this technology out there, and you're going to need to take advantage of it if you're going to continue to fly. It's going to have to be that way. I can remember some of the other things that have been going on. And if you don't think technology runs your life, just think about all the stuff that's computer-based, computer-oriented, and that you're using on a day-to-day basis. A cell phone. How many of y'all got cell phones? I hope you turned them off when you came in here so they won't annoy us when we get in the middle of things. Your VCR. You got a VCR or a DV recorder. You probably got one or the other or possibly both. I'm not asking for a show of hands, but I wonder how many of y'all have taken the time to read the manual so you know exactly how to get whichever program it is you want to see recorded on this thing so you can see it again. I wonder how many of y'all have little digital cameras, whether they be mini DVs or 8 millimeters or whatever, and we use all these little terms in there that describe the piece of equipment we've got. How many of you got those sort of things? Your microwave that you have at the house. The thermostat that you use to control your air conditioning and your heating at the house, or your heat pump. Anything that's got a remote, that sort of thing. The dishwasher in the house, in the new houses, they're controlled by computers. So is your washing machine. You go down there to Sears and you'll see the state-of-the-art dishwashers and washing machines that'll do just about everything except put the clothes back in your closet for you. Your ATM. I know that those of you all who are working, you're probably doing your payroll, time and attendance reporting, something like that, using some kind of computer technology. E-filing, your income tax, everything is done that way now. Email, internet, you use that for your shopping, your business. There's almost nobody that's out there that's not using a computer today to do just about the most mundane task around the house. Now, the penalty for not knowing a lot of these things is, in today's parlance, is going to be inconvenience. If you don't know how to use the ATM, you're probably going to be inconvenienced. I keep thinking about a television commercial I saw with the Visa, where they showed it during football season, where the people are going through the line at the fast food place and they're swiping their card and they're getting their food and they're moving through and they've got that repetitive music that's playing. And then one person walks up and hands the person cash, and all of a sudden everything falls apart at that point. Trying to make the point that this is an automated society, fully automated, and we need to get with the times. Okay, so you're flying your aircraft. Tell me you can't learn how to fly a technically advanced aircraft? Well, if you've learned how to master some of this other technology, you should be able to walk into and master most of the technically advanced aircraft that are out there. Good news. If you're flying Garmin equipment, for example, I'd like to say that for the most part, if you can fly or operate one Garmin, you can operate most of the rest of them, because that's a company that was pretty smart in putting together things that transition from one thing to another. If you're a boater and you have a Garmin GPS in your boat, there's a pretty good chance that you can operate the one that's in your aircraft, and vice versa. As I've got a little handheld Garmin, and it's great. I also fly the Garmin 430, 530, and now the Garmin 1000 stuff, and I'm comfortable, or feeling pretty comfortable, with most of the applications. Still got a ways to go, however. Now, it only seems like you're going to be starting out from scratch, but you're not, really. You get in one of these things, if you go over here to Cessna right next door and have a look at their Cessna 172 or their 182, that's in the yard there, and have a good look at it, and you think, wow, this is really something. The display in the front panel is really amazing and makes it a completely different airplane. Yes, it is a different airplane from the certification standpoint, but guess what? I've flown them. It's a Cessna 172. 2,400 RPM sounds like 2,400 RPM. The airplane don't know what's in the panel. It only reacts to who or what is in control. And so that's something you need to know. Funny little game to play when you get up there. See if you can hear the 2,400 RPM. Downwind, in the pattern, about 2,000 RPM, give or take. You can hear that. You don't need this fancy panel in the airplane to tell you how to fly it for the basic VFR stuff, but you will need to master it for some of the other stuff. You still use the same basic airspeeds and power settings. You can even still do an awful lot of flying just by looking out the window. That's the good news on all this. All you're faced with is a little bit of a different display on what you've got to look with. Remember the days of the old backward turning compass or heading indicator? Amazing. We've come a long way since then, haven't we? So what is really different? Well, I'll tell you one of the things that really is different, and one of the things that's driving the technology and really kind of driving your need to know how to deal with the technology, and that is the complexity we find in aviation. Airspace is a good example. There's more of it. There's more different kinds. Things like these special ADIZ and areas up around Washington, D.C. You need to know where it is and what's going on with it at all times. So that's a big issue. Weather depiction, weather reporting, you want to have the latest and the greatest, and it's out there. It's available for you. We don't all have weather radar, strike finders, and all this other wonderful stuff in our cockpits, but we do have access through this technology to a lot of really good, not quite real-time, but very close to real-time weather depictions that you'll find very useful. There are a lot more aircraft out there. Just the volume of traffic in many of these areas, and I know I live here in Florida, a lot of that traffic is out there, and you need to know more about it, and this new technology provides you a way of knowing what's going on. So basically, to succeed in the future of aviation, we got to be able to master this new technology. More aircraft are going to be equipped with it, as I said before, and they're going to be replacing the ones of the old days. When they find that they've got avionics in these old airplanes, they're not going to be able to replace it with some of this stuff, and you may not be able to get some of your old radios and things fixed. The pressure's going to be on to move into the better and greater stuff. It's light enough now, it's small enough now, and the prices are coming down to a certain degree. It is even now possible to incorporate this new technology even into the light sport aircraft that are being built out there and being shown over here at Paradise City. I mean, I'd like to see how they're going to be able to build a powered parachute that's going to have an altitude hold capability. That would be real interesting. But I suspect that it's possible. There's almost anything is possible these days. I'll tell you this. I've been through my own transition on all this stuff, and it started out with the Cessna 172 over at Embry-Riddle. And as an example, here is the course book that they gave us for the Garmin 1000 course. It was an 8-day course. And I spent most of the time picking my jaw up off the floor over what was being shown. And I go, I'm going to have about as much retention as a chicken wire soup bowl on this. And as soon as I walked out, I did remember a little bit, but it's only because I studied a little bit, I played with it a little bit, and I had a lot of help and a lot of instruction. But the more important thing is I've gone back and I've continued to reinforce what I already know. And that's what you're going to have to do in order to make the program work for you. So what is a technically advanced aircraft? Let's take a look at what a technically advanced aircraft really consists of. Basically, you need to have an autopilot in this thing. Build it with an autopilot. Put it together with a GPS, with a moving map display, which basically is all this requirement to make the program work for you. And this will also usually include all the other advanced stuff that goes along with it. A PFD, which is a primary flight display, coupled up together with the multifunction display. So all the stuff that you were used to seeing, for example, in the Cessna 172 that was round gauges has now been hidden behind the glass. Your engine instruments are behind that. You have to be able to read all of this stuff and know what's going on. It gives you digital readouts instead of a nice little picture-type display. Now, believe it or not, some of the big aircraft, like the Airbuses and everything, instead of giving you just raw numbers, will give you what it looks like the little dial with the yellow and the green arcs and everything else that go along with that, because that's what we are comfortable with. And if you can have that displayed in the aircraft in the system that you're using, whether it's an Avidyne or whether it's a Garmin or whether it's some other system, that gives us a bit of a comfort factor in keeping us up to speed at the same time we're using something that we're familiar with. So the basic differences between what we call the technically advanced aircraft and what I like to think of as the old six-pack aircraft with the 6 basic instruments. Here's kind of a side-by-side depiction right here. You can see that the standard instrumentation that you're accustomed to seeing is in place. A couple of advantages. For example, the attitude reference in the new technically advanced aircraft is actually a little bit larger than that old 3-inch diameter thing and gives you a little bit more information. You've got a larger display of your turn coordinator, and you've got a larger display of your heading reference. It's a little bit better, and also you can control the brightness of these displays as well. Pretty decent stuff, all things considered. Several differences, however, that you need to be aware of, for example, between the old and the new aircraft. They really expect you, if they've got the autopilot in there, to know how to use the autopilot. If you've got it installed and you're going to go take a flight check, you better know how to use it, how to set it up. I guarantee you, even if you don't, you're going to be tempted to want to use the thing, so you need to know how to use this stuff and need to play with it under good conditions before you get out there and have to do it in what I call combat, which is the real IFR. Learn how to use and navigate by way of GPS, and learn some of the weaknesses of the system that GPS will bring to you. So there's some of that stuff that you've got to think about. You've got to know that you're going to have a lot of information out there that's all overlaid, whether it's traffic, whether it's terrain, whether it's weather. You've got a lot of stuff. It's a very, very busy cockpit that you've got right there. And you couple that up with some of the other things we'll talk about later on, and you can see how your workload increases tremendously. It's going to require some new skills in order to give you the situational awareness you need in order to operate safely in the environment out there. You're going to have to prioritize what you're actually doing. That was the thing I found most difficult, because things were popping up, and before I knew it, I found myself out there playing whack-a-mole, trying to figure out what's the biggest threat, and also that my view was starting to move inside the cockpit, and I was becoming more of a video gamer, and I was paying less attention to the serious threats which were out there. Well, this is Florida. The biggest threats you got around here are the other air traffic. I had help, but I was constantly behind the aircraft in the early going. A lot of similarities, but there's also, each system is different. If you're going to work with a particular system and you know it, for example, me, the Garmin 1000 is where I've been working most frequently. That was basically an upgrade from the other Garmin systems and the other displays, so the step up wasn't quite as bad. But if you're going into something like these Cirrus with the Avidyne systems in them, you've got some learning to do. The other thing you're going to find out is they come with a big old fat service manual or an operations manual. In the case of the Cessnas over here, you're going to find that there's an absolute hard requirement that manual must be in the aircraft, just like the airplane flight manual. That is a requirement under the type certification of that particular airplane. No manual, no fly. Plain and simple. Also, there are certain other things that you have to be aware of. For example, you have a standby battery in that thing that powers the system when the engine is off. And you fire up that standby battery, and you're going to get that multifunction display going to come up, or I should say the primary flight display is going to come up, and it's going to have your engine instruments. That's how you're going to know what your oil pressure is when you start the engine, before you get everything wired and turned on. So that's the kind of stuff that you have to be aware of, and what all is in the manuals. The troubleshooting, every manual for everything I know, whether it's your TV, whether it's your remotes, whether it's your cell phone, they got a little section in the back of the manual on troubleshooting. Well, troubleshooting is no big deal, except that you're trying to figure out how to do the VCR just before the Super Bowl comes on, and you're not going to be there for it. Wrong time to do it. Okay, so you're inconvenienced and you miss the first couple of commercials in the first 5 minutes while you're figuring it out. Not a big deal there. Trying to figure this stuff out from the big thick manual when you're up there wishing you were down here is not the way to go. So that's one of the problems that you have with that. Okay, so what do we really need in order to get involved with flying a technically advanced aircraft? You need basically to be aware of 3 key flight management skills. Very simply, you got to be able to manage the information, you got to be able to manage the automation, and then of course, the topper of them all, risk management. You've got to be able to manage the risk that goes along with it. So we'll talk about each of these different things kind of in turn here. Under information management, let me go back up here a second. Under information management, you find yourself in a situation where you could be basically information rich but knowledge poor. That's not where you want to be. You want to be in a situation where you know exactly what's going on. Sometimes when you're finding yourself like that, you find yourself drinking from the fire hose. It's just too much information coming at you, and a lot of the good stuff is being mixed in with the clutter, and the stuff that's really important is difficult for you to prioritize. You have this primary flight display that's got your basic instruments, and it's got a lot of stuff overlaid with it. You could have a moving map over on the other side that's got your topography, it's got your weather, it's got your traffic overlaid with it, and sometimes you have some of these things that are duplicated. The Garmin 1000, for example, allows you to put a little inset map over on the primary flight display of what's on the multifunction display for the moving map in a smaller form. Just in case you need the second display of the moving map, it's there for you. So a lot of that stuff. There are menus and submenus. Sometimes things are hidden one page behind another. The Cessna 172, you don't even lean the fuel the old way like you used to. You know, you sit there with a mixture control and you roll it out until you saw that little RPM rise and everything, and maybe if you were sharp you could hear it and all. No. With this thing over here, you now have a lean assist, but it's buried a couple of menus back on the multifunction display. It is slick. It is a nice system, and it will let you feel real good about what you're doing. But the other thing is it tempts you into becoming a little bit of a number cruncher too. If you're the accountant type and wants to really get into there, you can play games with numbers at the expense of paying attention to the big picture out here, and that's one of the safety problems that you run into. One of the problems is going to be in knowing what you want, especially when you have to obtain the information in the heat of battle. And the heat of battle is out there when it's real busy and you're having to take air traffic instructions and you're having to convert that into action. That's not the time to be sitting there fiddling around with stuff. So this is where you need to be able to know the manual really well. I recommend that you take advantage of the little things like the cards and the cheat sheets that come with all this stuff, quick reference type things. Most of these have those quick reference cards and the quick checklists and all. Pretty good stuff. I would study and read whenever you get the chance. The night before the flight is not a bad time to, have a quick review of what's going on. The day that's beautiful out here where you're going to go out and fly what amounts to a profile almost exactly like the one you're going to need when you do go up north in the bad weather is not bad. A good way to do business. I would say use and take advantage of some of the simulation software that's out there. A lot of DVDs and CDs for the various systems are available that you can use. Here's one for Chelton that will give you an opportunity to go and play with the system. You put it on your computer and you can essentially fly the system, and what you really actually learn out of all that is all the knobology, all the things, all the menus, how to find them. It's just like having the cheat sheet right there. Do it under the safety of your own home, and then that way you don't have to put this to the test in the aircraft a little bit later on. I think Garmin will put, it's about $395 or something like that. I tell you right now, the National Association of Flight Instructors over here in one of the tents just over to the west of us here has an opportunity. If you join them, Garmin has got a DVD that they'll give you to go along with the deal to help you get up to speed on all this. If you're going to go check out in any of these aircraft that are for rent, one of the things you'll find is that the rental outfit, the FBO, is going to require you to have some kind of ground training, probably with some of this simulation software, so you're further ahead if you go ahead and get that stuff and use it in your own home, because now you can basically learn at your own pace and pick up on an awful lot of the good information that has to go along with you. Some of the other things, there's training going on all over the place. In fact, part of the article, part of my presentation today comes right out of FAA Aviation News, a real good source of information. There are 2 articles in this particular issue, the March-April 2007 issue, dealing with technically advanced aircraft. So read about it just about anywhere you can get a hold of it. Just about all the trade publications have got something going on the technology that's in their aircraft, and you can read up on all of that. One of the other things I would recommend is FAAsafety.gov, a great source of information. And this was a screenshot from just this morning showing that we've got several programs even in the local area. Here's one on transitions to the technically advanced aircraft. Are you ready? This is Thursday, April the 12th. That's already come and gone. But also we've got one coming up on May the 7th over in Portsmouth, New Hampshire. And of course, this is going to be a constant subject at a lot of different safety seminars all over the country. So there's a lot of resources out there on getting involved with flying the technically advanced aircraft. I would caution you, please don't get fixated on the knobology of doing all this stuff, because you can get yourself lost. Know the difference between, for example, the hard keys and the soft keys in the displays that you're seeing. The hard keys, for example, are up there on that audio panel, and those are actual switches. Every time you push a particular button, it does a specific function, and the function of that button never changes. Whereas in the case of the soft keys that you see down there at the bottom of the display, those can change depending on the screen that you have up there. And there are the little unmarked buttons below those marks right there where it says Inset, PFD, OBS, CDI, applying to particularly different screens. So you have to know what's behind each of those. It was really funny. The first couple of times I flew in the Cessna 172, and they were giving me, say, okay, squawk code so-and-so. Well, it took me a while to find that you had to use the soft key corresponding to XPDR for transponder, and then once you punched that button, a whole different row of soft keys popped up that had the different numbers 0 through 7 so that you could set these things and put the numbers in there, or 1 through 0 are all in there, and then you had the key that would allow you to go VFR that would automatically select the code 1200. So a lot of neat things, but you had to know how to find it. And the first few times of fumbling around through that, I didn't want to have to be up there in the soup trying to change those numbers with these buttons and finding these things if I didn't already know how to do it. So that's some of that other real good stuff. Some of these systems allow you to set in personal preferences into the system. Like, for instance, I don't know how many of y'all like to navigate when you've got the chart in front of you. Do you like to turn the chart so that the course line that you're going to fly is always pointing up so that you're always flying up the course line? Or do you just leave the map sitting whichever way it is with a course line going whichever way it needs to go? It all depends. People like to do different things when they fly the aircraft. So you've got the ability to change the display to suit whatever it is you like. Maybe you would like to reduce some of the clutter. I don't need to see necessarily all the air traffic or have all the airports displayed if I'm going somewhere. I'd be more interested in seeing the weather, maybe the terrain. And so you can select different preferences that will allow you to do what you need and give you the best and the safest means of using the system. One of the things you should definitely do is establish some procedures as part of your checklist. For example, one of the things that they have on a lot of these systems is a fuel computer. You fill your tanks up, you need to go into the system and tell the system how much fuel you've put on. Now, you've got fuel gauges that will tell you how much is in the tank, but the tanks aren't talking to the computer to tell you actually how much gas you really do have on there. So you have to go set that in there so that now it starts a countdown and not only will give you the information. In the case of the Garmin, if you run your map range out, you'll actually see a circle begin to appear that'll show you how far you can go before you run out of gas. Now, will this system let you run out of gas? You better believe it will. It'll let you fly it right till the engine quits. So technology is not going to save you from everything. You might want to set your flight plan in there as well. Get that set up. Do that while you're sitting in the chocks. Sometimes you can set your flight plan up before you start the engine. Real important little feature if you're paying for this on the Hobbs meter. Set this up before you start the engine, and then you can keep it in there and save it, and it's ready to go. So think about that. Don't be trying to do the advanced setup stuff while you're sitting at the hold short line. That's not the time to be doing it, because you know that as soon as you get to the hold short line, there are going to be 3 jets that are going to pull up behind you, and they all have to go right now. And the next question is, can you get around that Cessna or something along those lines? The whole idea is have it all set up. If you're using the GPS, also bear in mind, too, that the GPS is not approved as a primary means of navigation. We all know that. So that when you go to shoot the NDB GPS approach, you're shooting the NDB approach, but we know that you're actually using the GPS because it's more accurate, but it's not approved for what it's worth. The bottom line there is be the pilot in command of this aircraft. Don't be the passenger in command. Don't let this airplane take you someplace that you haven't already been 5 minutes beforehand. Don't be simply satisfied with, oh, okay, as far as I need to go with this is, I'm going to St. Petersburg, PIE, direct, enter. You know, there's more to the system. If you're paying for it, learn how to use it. Take advantage of the full throttle experience and learn how to use the system. It'll be to your benefit. As far as situational awareness is concerned, this is pretty basic. Know what needs to look right. If you're on a heading of 240 and the controller tells you turn right, fly heading 270, well, that's pretty straightforward. If you're set up right with your equipment in the aircraft, when you hit things, if it starts to turn left, it's doing something wrong. Something is happening that shouldn't be happening. So you need to double check your setups and make sure that everything is going to do exactly what it's supposed to do. See if what you're looking at makes sense. When you set up your flight plan, these moving maps will trace out the line for you, and if it looks right, you should be able to tell. If you look at it on your chart, if you look at it on your flight plan that you have written down, yep, that's what I wanted to do, you'll be in good shape. Remember that when you're pushing buttons, every time you make a move and you're pushing a button, you're making an entry of some kind. You have the opportunity with every button push to make another mistake. They say that when you make faster computers, what we do is we're making bigger, faster idiots. And I mean, you know, you can enter the wrong thing inadvertently, not pay attention to what you're doing. And, you know, if you enter, what would be the difference between, say, flying to PIB or PIE? Well, one is Pine Belt, Mississippi, and the other one is PIE, St. Petersburg. So when you double check, you go like, why is it telling me I've got to go about 480 miles to get somewhere, or 500 miles, when really I only need to be flying about 35 miles to get somewhere? So if you don't check this and you take off and you go like, okay, head to my first fix, which is Pine Belt, Mississippi, and the thing immediately turns right and you start heading you northwest, you go, that's not right, then you got yourself a problem. A little recommendation. Do call-outs. We call call-outs. Say it out loud to yourself what it is you're supposed to be doing. If they say, climb and maintain 4,000 feet, and you go 4,000, and you punch in 4,000 feet on your altitude arm and hold, and you go altitude arm 4,000 feet, and you look at the display and see that it says that it's armed, and it's actually taking you up to that. You don't want to be surprised when you get to 4,000 feet and you're not paying attention and it flies you right on through it. The next thing you know, you're getting a call from air traffic saying you're off your altitude. And then when you get on the ground, we want you to call and talk to the tower. Here's the phone number. You don't want that. So do that. Make the call-outs. Heading assignments. Turn right, heading 270. 270 is set. Believe it or not, this is what the professional flight crews do for the air carriers. They have two pilots up there in these aircraft, and air traffic will call them up and say, descend and maintain flight level 260. The guy goes up. One person who's the pilot flying the aircraft makes the heading or the altitude shift in the equipment, points to the equipment and says 260, and the other person points to it and says flight level 260. Now everybody's in agreement. The equipment's in agreement with the two people who made the change and made that so. So it's make it so, number two. So it is. The same thing with fixes. When they put in, they say, we're going to select the ILS runway 5 approach. And they select and say ILS 5 approach selected, and then they name off all the fixes, final approach fixes, wiry, and so on down to Lakeland, whatever. This assures them that they have done everything and they've done it right and they've entered it properly. If you've used the little hand calculators or if you've used your cell phone, it's easy to make a button push that doesn't go the right way. I like the old idea of flip the phone open and you go hit one thing, call, home, say it, and it automatically dials the number for you. I like that. You can't do that in these airplanes. They still want you to make all of these entries. Okay. Let's talk about automation management. automation management, we talked to George, our autopilot. This is what the autopilot control box looks like for the Cessna 172 or all those that are using the KAP 140 system over there. The 182 uses it, but this is also hooked into the Garmin G1000. What you're trying to do here is avoid what we call automation surprise. The way you know automation surprise is when you go like, I want it to do something and it does something else, and you go, well, why did it do that? Or what's it doing now? Well, guess what? That is a state of denial. You didn't do it, or so you think. The autopilot did it. George did it. Well, George is only doing what you told him to do. And if it's not doing what you're supposed to do, or what it's supposed to do, now you got a decision on your hands. I know what a lot of y'all are thinking, because I've done it myself. You're all too quick to reach for the red button, which basically disengages the autopilot. Well, if you had done your job in the first place and then double-checked what you'd done, then you shouldn't get any automation surprises. And you don't want any automation surprises, for example, when they're going to clear you for the ILS runway 36 right or 36 left in Tampa, and you fly through the approach course and you're heading for 36 right because you haven't got much time before you're going to have a loss of separation between you and another aircraft. So that's a problem. So what you want to do is not find yourself in a situation where you're the passenger in command riding along with George doing the work. George doesn't do what it's supposed to be doing, and the next thing you know, when you reach the red button, you've gone from being the passenger in command to now being the pilot in command of an aircraft that to you is essentially partial panel and in combat. And that's not where you want to be, because at that point you are playing some major serious catch-up, and you're trying to go and reprogram everything and reset the approach and stuff like that. So you really need to pay attention to what's going on. Know what modes of your autopilot are engaged, for example. And this is where you want to use your call-outs once again. For example, I've got heading mode established. We're in the approach. I expect this thing to capture the localizer, and you can look and see that you're looking for the indications. The localizer is armed, basically, and when the light comes on and says it's captured, you're looking for the aircraft to turn and intercept the localizer. Everything's going the way it should be going, and you're just basically, at that point, double-checking that what you've done, except that you're double-checking it for real now. So all of those things. Know what George, the autopilot, can do. For example, does your autopilot capture the glide slope from above the glide slope if you have to suddenly roll this thing to a high rate of descent? Will it capture it, or will it try to fly through it? What are the limitations on it? What is the angle of bank that this thing uses when it goes into a turn? What are you looking for? When you're doing a GPS approach, for example, are you aware that, for example, outside 30 nautical miles from your destination, you should have a display that tells you that you are in the en route mode? Full-scale deflection of the CDI for your GPS is 5 nautical miles. When you get within 30 nautical miles, little light comes on, it goes from en route to terminal. Now you're within 30 miles, and full-scale deflection from your course is now only 1 nautical mile. And if you set up the approach and you're going to go in and shoot the approach, when you get to within 2 nautical miles of your final approach fix, now that full-scale deflection is down to 0.3 of a mile. You're getting much closer sensitivity as you go in there. And that's the kind of stuff you need to know. And your autopilot's going to try to fly to those particular standards. Know also how your autopilot interacts with all the other systems and how to fly the aircraft in several different modes. Well, now, everybody likes to hand fly the aircraft, and you always want to know how to hand fly the aircraft because you're probably going to have to do it. You're going to probably have to hand fly it for takeoff, and you're going to have to hand fly it for landing. And if you don't do anything else in between and you're letting George do it, you need to know how George is going to work with everything you've got. The ways that I was always taught to fly, basically, and hand fly was the first thing. We didn't use any of that stuff at all. And you can do that. Great VFR, you can use all the stuff as sort of a backup and just kind of double check. I mean, I can fly from here to Clearwater, St. Pete without having to turn anything on, really. On a clear day, you can just about see one place from the other. Pretty simple stuff. Not a bad idea to know how to hand fly, but use the flight director. It's got basically the attitude, and it's also got the little director that tells you, okay, your course line is to the left, and it's going to kind of tell you to turn to the left, and it's going to give you the little indication you need to be turning to the left, but it expects you to do it. Autopilot has nothing to do with it. You're on your own flying this thing. But the autopilot's not doing, so you're flying the flight director. And if you don't have your navigation stuff set up, you're thinking, well, I need to turn right to intercept the localizer because there it goes, but for some reason, you've still got the heading mode on, and the thing is telling you, keep flying straight ahead. You go like, I'm supposed to be flying the localizer. Well, what are you going to do? You're going to believe me or your own two eyes? So you've got to be ready to fly the aircraft and make sure it's set up. Now, you could fly just the autopilot, get up there, forget the doggone navigation. We're not going to do navigation mode. We'll just do heading hold, or we'll do altitude hold maybe. Or maybe we'll just put this thing in the basic wing leveler mode so that, you know, if you get a little bit of turbulence, the thing comes back to wings level. It may not hold a heading for you. It probably won't hold an altitude for you, but you've got the ability to select those things, and then you use knobology. You turn the heading bug, and the airplane will turn for you to do whatever you need to do. Just flying basic autopilot at that particular point. The full Monty comes in when you decide to hook the flight director into the autopilot and fly all of these things together. That's where George is now taking command of the whole thing, and you have to be sitting there babysitting George like a hawk. And that's the full Monty. Now, you can back out of these things in stages by degrees and do what you need to do. Going for the red button is going for the whole 9 yards. That's sinking the ship, basically. And if you're ready to do that, you're on short final, the gear is down, and you say, okay, George, you've done a great job. My turn. I've got control. And then, of course, you go and you hamburger the landing porpoise at about 4 or 5 times. You go like, geez, what did it do that for? So you want to watch out for that sort of thing. Okay. So you figure out what works best for you, and then you go with that. Final thing we want to talk about here is the risk management aspect of things. Enhanced situational awareness and automation capabilities can expand your safety, and they can actually help your utility and make you a more efficient pilot. They can really do a lot of good things for you and make you the master of situations that are the kind of thing that introduce a lot of complexity into your life. It'll help you visualize things that you might not have the ability to do as easily if you're sitting there looking at a paper chart. A moving map telling you when you're getting close to the edge of the Class B airspace will help you make decisions. It does that. But at the same time, I would caution you, please don't let it tempt you to shave your safety margins. Just because you see what you think is hazardous weather and it's very nicely outlined and all, doesn't mean that you should say, well, I can fly that much closer to a thunderstorm. Remember the old aviation weather thing about 25 nautical miles from a thunderstorm? The safety margins that you had then work just as well now, even with all this wonderful stuff. It's not a substitute for a good set of eyes. It's not a substitute for good judgment. Not even the slightest bit. I can tell you from my own experience that having an aircraft with an autopilot, with a flight director that has the ability to see traffic with traffic advisory and all, it calls out the traffic to you, having a co-pilot sitting in the airplane, and also being on an IFR flight plan with an air traffic controller sitting in front of a radar scope tracking my mark across a screen has not kept me from having close calls in the airspace with other aircraft out there. So the risks are always going to be there no matter what you've got in the airplane, whether it's you and the other pilot or just you by yourself, or whether it's you coupled up with your autopilot and all this other wonderful equipment that's supposedly working for you. The hazards are still out there. Like I said before, do not ever let an aircraft take you someplace that your mind hasn't gotten at least 5 minutes before then. And please, don't let George allow you to become complacent. Don't get fat, dumb, and happy with what George is doing for you, because George may have been flying the last 2 hours worth of great flying. And if you haven't got things set up properly, you can get that automation surprise and be waking up from a sound sleep. A wonderful trip can suddenly become a harrowing experience. Remember, you're still the pilot in command. Don't become the passenger in command. The same good aeronautical decision-making skills that got you this far are the ones that are going to get you beyond and through and into the technologically advanced aircraft of tomorrow. They really will. So you should incorporate the technical advancements into your decision-making skills and make them part of it. One of the things that's worthwhile is to remember the old risk management checklist and the old personal minimums checklist. We taught this before we started getting glass cockpits, and it still works just as well now. So you go through this and you evaluate your go, no-go decisions on the same basis that you did before, bearing in mind that you might have a few more capabilities. I always felt a lot better in the good old days when I just had DME. Boy, I thought that was the greatest thing in the world because now it gave me ground speed. Wow, a great leap forward. A lot of things for us have been great leap forward, in a lot of ways. For some folks, it was probably just having a little piece of glass between them and the bugs that were hitting them in the face. That might have been it. But nowadays, the glass contains all this information. So, the pilot, evaluate your own ability to fly. Are you ready to fly? Do you meet the regulatory minimums? Have you had your 3 takeoffs and landings? All of these kinds of things go into it. Do you have what you need in order to meet that requirement? Evaluate that. Make a go, no to go decision on the basis of that area. Evaluate your aircraft. This is where the new technology comes in. The old aircraft that's day VFR only obviously has its limitations. You're certainly not going to make a decision to go fly at night if you don't have the lights on the aircraft operating properly. By the same token, what are going to be your limitations as far as IFR operations? Of course, the regulations are that thick as far as that goes. But build into that now the new technology, and what is your system really doing? And don't think for a moment that these new systems, as reliable as they are, don't have some unreliabilities in them. And they will show up from time to time. As a matter of fact, the aircraft I was flying recently had a little problem with the heading hold. If you wanted it to hold a particular heading, and if you were given a particular heading, you turned the heading bug, you had to turn the heading bug exactly 12 degrees to the right of the heading that you wanted. So if you wanted to fly heading 270, you had to set it to 282. That's not a very good situation because now it's forcing you to do a lot more thinking up here. I can't just simply go select 270. Air traffic will call me and we'll have a little issue about that. So this is one of those things. You, flying a technologically advanced aircraft, are going to have to become a little bit of a troubleshooter too. If it's not doing what it's supposed to be doing, you need to be able to write and describe a very good write-up for a maintenance professional to handle the situation. You need to be able to say, well, I selected altitude, 4,000 feet, had the proper altimeter setting in there, and this thing leveled me off 250 feet low, and then it slowly crept up to altitude, but it took about 5 minutes for it to actually get there. That's a discrepancy somebody can actually do something about because now they go into the higher technology areas and they work on that and they can address the issues. You need to be able to say specifically what it needs. This is what you're going to do when you buy this equipment and you have it installed in your aircraft and you get the nice warranty with it, is be able to properly troubleshoot your equipment. So that's part of the aircraft side of the house. The environment, it's the same environment we've been working with for years. The weather is still the weather out there. You're still going to have to deal with whether you're flying in the high terrain, stuff like that. Density altitude is not going away. Being involved in any kind of stuff, whether it's at night, whether it's over water, the same hazards that are going to be there with a technologically advanced aircraft were the same ones that you were dealing with a long time ago. So you've got to evaluate that. And then finally, guess what? This has nothing to do with the technological advanced aircraft. This is the external pressures. You got the get-home-itis. Are you in a rush? Is everything going to be okay? Are you working real hard at this thing? You might be working too hard at it, and you might find yourself too tempted to take advantage of the technology and sacrifice a little on the side of safety. Don't do it. Please don't do it. The bottom line here is that technology should enhance safety and not be a substitute for sound discipline. Let's face it, the technologically advanced aircraft is not going to put gas in your airplane. It won't do it. It's not going to move the mountaintop that's right in front of you. It's not going to do that. It's not going to lower your landing gear for you. I know there are folks who will say, yeah, it lowers the landing gear for you. Auto land system. You know what? I don't care how good it is. Do you know that the pilots of the space shuttle still have to lower the landing gear? They have to do that. be a heck of a deal to be orbiting the Earth and come in and make a really nice approach and landing and then land gear up. But I can guarantee you that there is nothing out there that is actually going to prevent somebody from landing with the gear up except the people who make the decision to move the handle in the proper direction and get it where it's supposed to be. So it won't do that for you. It's also not going to move or freeze the other aircraft that's out there on a collision course with you either. You can't simply say, ooh, screen freeze, let's go back. This is not a simulation. This is the real thing. And the real thing is what you see out there and what you manage. You have to manage all those conflicts. It's not going to apply the brakes for you at the hold short line to tell you you're about to have a runway incursion. It won't do that. It also, I noticed, won't talk for you on the radio either. So if you've got problems with that, that's another thing you'll have to deal with. Well, with that, I've pretty much had everything I had to say about this, because I'm not going to teach you how to sit here and fly, and I'm not going to give you all the specifics of a specific system. Plain and simple, not going to happen. You got to go out there and do that yourself. So with that, I'll go ahead and I'll entertain any questions that you might have. We got a few minutes. Yes, sir. We got one down in front here.
Yes. Why aren't Hello. Check.
Okay, we got you.
Why isn't the FAA allowing light sport aircraft to have IFR equipment and fly IFR?
Well, it's more a matter of the level of certification, I believe, for the pilots. That if we're going to allow somebody to operate, they need to have all the IFR skills themselves. It's not to say that I don't think that you could probably get an aircraft. I don't know if you can get an aircraft certified as a light sport for IFR operations, but that was never really built into it. And the same thing, the ultralight air arena never provided for IFR operations of ultralights. In fact, they never even really envisioned them being in a situation where they would take advantage of some of the more restrictive airspace. They put a lot of restrictions on all of that.
But if you're an IFR pilot now.
Yes.
You're an IFR pilot now. You got the rating.
You've got the rating,
You're going
yes.
to fly light sport aircraft that is equipped with equipment. You're not legal to fly at IFR.
Right. That's correct.
And it doesn't seem to make any sense because it's a safer way of going.
Well, it would be safer to operate in the IFR environment if you can do so. And I'm not certain exactly what it is. What it is about the light sport aircraft that is locked that out. But it's something that's built into the rules as it stands right now that doesn't allow them in there. Now, I do know that there are many aircraft out there that can be operated as a light sport aircraft by somebody who holds only a sport pilot certificate, but they are now restricted to those particular privileges as sport pilots. And even though it's a certificated type aircraft, Champs and Tabrias and some of those things like that fall into that particular arena. But what you're talking about is a genuine light sport aircraft. I know the technology exists to do that, but I'm not sure exactly what the criterion would be in order to get that particular aspect of the rule changed. Remember, light sport covers a wide variety of aircraft, including things like the powered parachute and the weight shifts and everything else. And beyond that, I'm at a loss to try and explain it to you. We can probably even explore that and talk about it on the break. Any other questions? I have one back in. I have one right here.
Is there a procedure for a complete electrical failure for the system?
Yes, actually there is. The electrical failure procedure, for example, for the Cessna 172 is that you've got a standby battery. You've got a regular battery already, plus you have a standby battery, which when you're working on that will give you the primary flight display, and it will still give you the engine display. So you need to have that, and that's one of the things that's a required pre-flight item is to check the condition of the standby battery. That's already been built into it, and that's by regulation as part of the type certification of the airframe. I think we have another one here.
In 1984, the FAA came up with a standard steam gauge cockpit arrangement. The altimeter goes here, the artificial horizon, and so on in the DG. The question is that there are older aircraft that didn't meet that standard. You can now upgrade an older aircraft to a TAA standard because one of the companies, Garmin, now has a glass panel that you can replace all of those steam gauges with. So you simply remove all the old gauges and put in the new. You've essentially leapfrogged over that standard. and now you have a TAA aircraft if you comply.
That is correct.
Put it all in there. So
that is
yeah.
basically correct, because you met what amounted to the standards for a technically advanced aircraft, even though it's into an older airframe. A lot of these old things like Beavers and stuff like that in Alaska are flying as technically advanced aircraft.
Right.
And even though it's an old round engine and all, they're taking full advantage of the technology that exists out there.
Okay, thanks for affirming that.
You bet. You bet. I thought I saw another question right up front here.
I have more of a comment than a question, but it's a dilemma, and I wonder how often you are faced with it. I get really excited when I hear a good lecture like yours about the technically advanced aircraft, but I rent airplanes, and I don't always fly the same airplane. And sometimes I wonder if I should bother learning all this if I can't fly it often. I mean, it's like flying a multi-engine airplane. You have to fly it a lot to be proficient in it.
Well, you make a good comment, and you address a dilemma that we all face. With the cost of aviation being what it is, the time we spend doing it is at a premium, and for that matter, the money that we spend is at a premium as well. The advantage we have with technically advanced aircraft is, and I mentioned it before, the CDs, the DVDs, and things like that. There's simulation software out there that's available at a fairly nominal cost that allow you the ability to go out and fly what amounts to a computer flight. In that sense, even though you're not physically controlling an aircraft, you are controlling the technology, and you have a leg up on managing some of the issues that come up. Now, it's not going to sit there and throw weather at you and all. If you go out, you'll find that some of these training schools and all do have the ability to introduce some of these other parameters into it, and they use that. If you're not flying frequently, that's going to speak to several other issues as well that are not related to technical advancements. I mean, things like the takeoffs and landings, the IFR currency, and that sort of thing. And that's something that has to be balanced into all of this. There are provisions to allow for simulation to account for a certain amount of the regulatory currency requirements. And there are also other things that you can take advantage of. For example, our FAA safety.gov has a lot of things that are going to be coming up on this new pilot proficiency program, and I think industry is going to join in with us on trying to offer some of these things. A lot of these are going to be directed toward the technically advanced aircraft. But I certainly thank you for that compliment. Anything else? Well, if that's it, I certainly hope you enjoyed the rest of your stay here at Sun and Fun. Fly safely. Come back and see us again sometime real soon. Thank you very much.